This is section 2.7 part B, and we're talking about compound inequalities, which are equations that have two inequalities. So looking at this, you can see that we have a, let's just grab it here, highlight. You can see I have one here as well as there. They're compound, okay? So that means two. Now what I'm going to do is, this notation, this compound inequality, will always be an and, okay? So this look is an and then the previous look, well, guess what we're setting there? The word or, right? So if it doesn't say or, and it looks like this, it's compound, two inequalities written as one statement, then you know it's an and. Now, what we're going to do is we're going to split it. And what I mean by split it, we're going to take the equation, and it'll be negative 3 less than 3x plus 1. That'll be one of the equations. And then we'll take another one and do the 3x plus 1 less than equal to 13. Now, what you have to pay attention to and really understand in this is when you multiply or divide across the inequality, we have a negative coefficient, then it's going to give you a flipped inequality. So it's gonna want to make you flip the inequality on that. Okay, so we're just going to go ahead and solve these. So negative 3, negative 1 gives me negative 4 less than 3x. And of course we'll divide by 3. So we'll x greater than negative 4/3, right? And then we'll come over and solve this one. We'll go minus 1. So we'll do 3x less than equal to 12. And then we'll, of course, divide by 3. And because the 3 is positive, I don't have to worry about the inequality switching. Now it says write it as interval or inequality notation. In inequality notation means that if I were to take this, ungroup that, ungroup there. If I was to take my answer here and move it over and line it up, then that would be what my inequality notation would be. So my answer here would be negative 4/3 less than x less than equal to 4. And the alligators will always be eating to the right. Okay. We say alligators, we're talking about inequalities, right? But that's really what happens. So this was my answer, and I just put my x's over top of one another, and there it is in the inequality notation. Now let me move this back. If I were to have to do this as, well, I won't say that. Boom. If I had to do this as interval notation, then here's what I'd have. I'd have negative 4/3, and then I'd have a 4. Okay. I would have, because this inequality is just without an equal to, it's an open dot, and then this one is a closed dot. Now what I'm going to do is I'm going to take this. Okay, so what we had taught prior, and I'll hit it here in a second. What I'm doing to this right here is I'm rewriting it such that the x, the variable, comes first. The inequality is still going to eat the x, right? It's eating the x here. It's going to eat the x there. Now, if it is like this or like that, it's an open dot. If it is equal to, less than or equal to, it is a closed dot. And what that means is, if it's an open dot, huh? No, it doesn't matter. It, no, well, I'm not there yet. So the open dot, the greater than or less than, will not include that number. But the greater than, less than, equal to, which means it's a closed dot, means it will um, include that number. That number is part of the solution. For an inequality, it's not just one number, it's a range of numbers. Okay? So, because if you put the variable first, it will point in the direction that the values need to go. So values greater than negative 4/3 would be um, to the right. Okay? And then values less than 4. See how the inequality is pointing when the variable is first, the inequality will point in the direction that the line needs to go. It goes that way. Now, they're only touching, an and is an intersection, right? So it's only where they touch, and they're only touch right here. Okay? So when we write this as interval notation, we're talking about negative 4/3 and 4. Now, because it's an open dot, it will get a parentheses. Because this one is a closed dot, it will get a bracket. Okay? So those are things we've got to make sure we understand as well. All right? Any questions on that? No. Closed dot doesn't mean, closed dot means it doesn't include negative 4/3. If we will smush them, these two lines only touch from negative 4/3 to 4, but not including negative 4/3 because it's an open dot. Not included, right? Open dot, not included. These are the inequalities right here. And then these right here are closed dots. You see the equal to, that means that's included. That would actually be a bracket. If you see those, they would get a bracket. But if it's just greater than or less than, then it's just it's just going to be a parentheses, because a parentheses mean it does not include that. Okay? All right. So let's go. The answer to this interval notation, the answer to it is right here. So it'd be parentheses negative 4/3, comma, 4 bracket. Okay? Now, let's go work another. On this one, it says graph the solution set absolute value greater than or equal to negative 15, right? So we got an absolute value, right? Nope. Hold up. Yeah, there'll be some closed dots, but this right here, this, we're looking at absolute value, right? So what we have, huh? Yeah, the absolute value is on x, but when you have an absolute value of x that is greater or absolute value greater than or equal to, you have an or. If you have an absolute value that is less than or less than equal to, you have an and. Okay? That's very important, because when you look at absolute values, you have to read it in order to know whether it's an and or an or. Okay? Because an or is a union. That means it can satisfy this one or that one. Doesn't have to satisfy both of them. But when it's an and, it's only where they cross, right? It's only where they touch. So, and you got to make sure that the absolute value is isolated. Okay, so it's got to be isolated. They can't anything else be over there except for the absolute value bars and what's in between them. So what we've got is an absolute value greater. Hear that? Great or. Okay. So if you think about that, we're going to have a positive and a negative. It's going to be an or, right? And what I mean by positive and negative equation, we're going to say x is greater than or equal to negative 15. And then we'll also, for the negative, you remember when we did absolute values, just solving absolute value equations, period. On the negative equation, we multiplied the right-hand side by negative 1. Now, in doing that, this is what's going to happen. Here's your x. If I multiply this right-hand side by negative 1, that's really, I'm doing it to both sides or across the inequality. What it's going to do is flip it. Okay? So the negative is going to flip inequality, and it's going to multiply right side by negative 1. Okay, so that's how we set those up. So if you look at this, I'm going to kill some of these things right here because I really don't. Well, you know what I'm going to do? I can't because it's already hard coded in. So I'm going to kill that right there, and I'll kill that right there all the way up to there. There. Now I'm going to make that negative 15, and I'm going to make that positive 15. Okay? So, for this one, x comes first, greater than or equal to negative 15. It'll be a closed dot, and it'll be going to the right. Okay? Now on this one, it's also a closed dot, right? Because it's got the x is less than or equal to, but it'll be going to the right. I mean, not right, left. Now, when you have this scenario right here, what you're saying is, and this is for an or, is you're saying that all real numbers, right? So basically, you're saying everything from negative infinity to positive infinity. And this is one of the looks. It's like 4 looks that you'd have for an or on some absolute value, or just absolute value inequalities periods, or just inequalities with, or compound inequalities. You'd have them same things with ands, but as far as the number of scenarios. But because this one starts over here and goes to the left, and the other one starts over here and goes to the right, basically, now it only has to satisfy one of them, right? So every number satisfies at least one of these, right? So the answer is negative infinity to positive infinity. Okay? Yeah. If it's like this, yeah. If it looks like this. So what we really need to do is I need to just do this. I need I need to just show you some stuff, and that way you'll see you'll have a better understanding on some things. Maybe I need to do some things over here as well. Okay. So let's say we got, I better change colors. A, and we'll do B. Now these are for ORs, right? So what it's going to be is this. Um, it'll be, uh, the answer will be for this guy. Now I'm going to use a bracket. It could be a parentheses, right? This could have been an open dot. So the answer for this would be parentheses A, comma, infinity, right? Because if they're going this way, right? Now if I had and they're going this way, right? Both of them are going this way. Then what I would have is negative infinity all the way up to B with a bracket. I guess that right there needs to be a bracket too, since I said it was included, right? So if it looks like that, that's what it's going to be. Be the furthest point, because it's got to work in both of them, right? Well, not in both. It only has to work in one of them, because we're talking about an OR. Now, if we're looking at this, here's A, and here's B, and they're doing this, okay? Then what you have is two things. You have negative infinity to A, and then you would have B to infinity, and you have nothing in the middle, right? And you would put a U for union, because that's what an OR is, right? Um, and then last case would be, let me move this one down. A, B, and now I'll pick this one up, right? And then this is case, that's what it is, right? So there's four looks for OR, all right? So that's what you got to make sure that you are aware of. Fair enough? Yeah. The OR is probably the easy. Well, I shouldn't say the easiest. The one that gets you the most. The and is an intersection, so it's only where the two would touch, right? Would be the answers. And like up here, if this right here, we had this scenario, and it was an let me just do this. Let me go here, and let me go clone. There we go. Now let me change this to an OR. Change that, change that, change that, and change that. Now what I'm going to do now is look at in terms of an and, right? These four looks are going to be used for ands, and they're going to be used for ORs. For this one, it would be B comma infinity, because it's only touching from B on, right? Does that make sense? And then this one would be from negative infinity to A, because it's only touching from negative infinity up to A. For an and, it's got to touch both together. On this one, it would be, no, it would not. I just made a mistake right there. It would be from A to B. And of course, these are closed in lines, so therefore they get brackets. If they're open, they get parentheses. Now, this scenario up here, they don't touch it all, and what we call that is an empty set. Okay, so there's your 4 looks for an OR and your 4 looks for an AND. Okay, and that's what you're going to come across. So knowing how to write these based off of that is going to be helpful. Okay. All right. So looking at this, we're going to read it. I can't read it now because guess what? See that right there? That's on this side. So first thing I got to do is -5. So absolute value, great OR, 4. So what type of compound inequality is it? OR, because absolute value, great OR. It's an OR, right? So there we go. Now we're going to have a a positive equation and a, guess what? Negative equation. The positive equation is going to look exactly what's there. But the negative will do 2 things, right? We'll flip the inequality, and then that 4 will become -4 because we'll multiply it by -1, right? So, huh? Yep, for the negative. Yep. So it flips the inequality, and you have to multiply the number on the right-hand side by -1. So let's go plot these. We've got a solid one. Well, you know what? I ought to do them in the colors I've got. I got black and red, so let's do black and red. I got a solid, and it's because the variable's first, it points in a direction, so it's going this way, right? To infinity, correct? Uh, we can check them. Okay. So okay. So let me finish graphing mine. So I got -4. It's a closed dot because there's my equal, and it's going this way, right, towards negative infinity, right? So we have an OR, and they're going in opposite directions. They don't cross, do they? Remember? So therefore, what I'll have is I'll have negative infinity to -4 with a bracket, and I'll have 4 to positive infinity. Now, the land that's in between that nothing happening in, you put a U, and that's the answer. That's correct. Yes, two sets of answers because an OR, it only has to satisfy one of them to be an answer, right? So what we're saying is every value from negative negative infinity to -4 is one possible answer, and everything from 4, including 4, up to infinity is also an answer. Okay, and because these don't cross, see, it's going to look like it'll look like this. See how they right here? Here's my OR, right? Here's what my 4 looks at OR. See how they don't cross? You put that U in between, right? Yeah, they look like that. There you go. Bottom right. Then, then it would look like that. Oh, it's still this right here is the answer for this every single time, whether it was open or closed for these. For this bottom right one, would always be negative infinity to positive, no matter what. One, yeah, one answer. Yeah. Now, um, you want to work this one and then see what we can do because we're pretty close. Yeah, about 3 more problems and we'll be done. Um, what you want to do? You want to work it and then check it? That's correct. You have to isolate the inequality first to determine whether it's an or an and, right? Yeah, you do. Read it. That's right. I got to have two equations. Why do I have to have two equations? Be- no. Well, it can be an and have two equations. It's an absolute value. Absolute values are always going to have a positive and a negative equation, right? Or this, or is a compound inequality. It means a union. It means all of this right here back at the beginning of 2.7. There's compound inequalities. There's ands or their ors, unions or intersections, right? So what you're doing as you're building this, you're coming through, you're learning how to write in the interval notation and inequality notation. Then you're taking it from interval to inequality, from a number line to interval, right? It talks about closed dot and open dots here. Now this is in the first video. And here is just solving a basic single inequality, right? Single inequality is not an and or an or, because ands or ors are compound, meaning two, right? And then we scratch that one. Now we're getting into, okay, so, hey, they're saying it's or. So you know you got a set of answers. And this one is an and because it's written like that. And then we went over why this one, we looked at absolute values, right? How to read them. Absolute value has to be isolated. It's either greater or less than. Greater is an or, less than is an and, right? So that's going to lead into, when I go to graph my answer, what is my answer going to look like? And it's going to be one of these four looks if it's an or it'll be one of these four looks if it's an and. Okay, there's not but four looks you can have in either one of them. Okay, now you got to know what you're looking at first. And in this particular problem that we're looking at, it's an absolute value. I know it's compound, right? Because it's an or, right? We said it's an or because absolute value great or means it's got to have two answers, compound. So what we do is bx minus 2 greater than 6. Then we have x minus 2 less than, because it's going to flip for the negative, and that 6 can now become negative 6 because we'd multiply it by negative 1. Okay, now we can solve them. And when we solve them, we get this. X is greater than 4, and then we'll add 2. And we get x is less than negative 4. Okay, it's an or, right? Or, oh, it's an 8. Just look like a 4, right? It's an 8. I added it wrong. I was just going too fast. Okay, so what we're going to do is we'll put negative 4, and then we'll put 8. We'll put infinity out here, and we'll put negative infinity here. Don't have a clue of what, those are my things, right? So let's graph this one. X greater than 8. It's an open dot going this way. This one equals. That's right. That's right. And this one says x is less than negative 4. Points that are less than negative 4 are to the left, right? Now, Not bracket. It's an open dot. Parentheses. Because an open dot means it doesn't include that point, right? Yeah. See, there's the dead man's, what we call dead man's land between it, where they don't crisscross, they don't even touch, they don't do anything. So how do I represent that? It has to be a union, right? And that symbol U represents an OR. Okay. So the blue down here is the answer. All right. Is it? Um, it's still. Is it an or an and? Well, can you make the determination just by looking at it? Why? No. The only thing over here on this side is the absolute value, right? We have to isolate the absolute value, then we can read the inequality, right? So it's the absolute value, right? Absolute value like this is the NOR. If an absolute value is like that, it is an and, right? And only the absolute value, right? Yeah. Yeah, the inequality, yeah, the alligator, yeah. All right. So you all right. So you said it was an or, right? So it'd be x plus 5. Did you get the negative side? Did you flip that inequality? Yeah, you got to. There's two parts on that. Flipping the inequality and multiplying the right-hand side by -1. Okay, if not, that's really going to mess you up. How about that? Oh, okay. That's right. And those are not closed dots, so they get parentheses. Now, negative infinity and positive infinity will always get a parentheses. Okay, yeah. So how'd you do? Yeah, it's once you start to see the pattern. But what I would do if I were you, I would take some note, an index card, and I would write down about absolute value inequalities. I'd write down my little things about, you know, how to read it, right? How to determine if it's an and or. Uh, that it takes two equations, a positive and a negative, and what happens to the negative equation, right? It flips the inequality and multiplies the right hand number by -1. So those things, so when you are looking at one of those, you grab that, boom, 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 all of that's right there, and then the other side could be a worked out problem, right? so you can really quickly bring everything that you know back up to your mind. Okay? Now, you want to do it? All right, so we've got -5, -5. So t is less than 9. I got -5, -5. T is greater than -19, right? You agree? So I got -19. I got 9. These are both greater than or less than, so therefore they would be open dots, right? Now, because the variable came first, this 9 would be, going, uh-oh, I hit the wrong one. It would be going this way. And the 19, because the arrow, the inequalities t is less than, or t is greater than -19, would mean that every number to the right, let me do something real quick. Every number to the right would be, but we're only looking for it because it's an and, we're only considering this right here. And only between these two, because that's the only time that both of them touch, right? But they don't touch. They don't touch at the -19, and they do not touch at the 9, but they touch everywhere else between. And that's what an and does for it. Nope. Well, you wouldn't have that because, see, they're not going that way. They're not going in opposite directions. Well, they are going in opposite directions, but they're overlapping one another. Okay? See how they're going in opposite directions and they're overlapping one another? If we look back here at an and, these two are going in opposite directions and they're overlapping one another, so therefore the answer is only between here. Okay? These would be for an and if they were going in opposite direction but didn't touch, it would be an empty set. Okay? So all the answers that satisfied this particular thing would be between -19 and 9. So it says the average temperature in frostbite falls over the course of years given by this in degrees, solve the inequality. Well, the average temperature is between -19 and 9, not including -19 and not including 9. Okay? Fair enough? You can't solve it. You can't solve, see, if you went back and looked at the beginning of 2.7, we're studying compound inequalities, right? We're going to look at single inequalities, meaning just one. But when we get to compound inequalities right here, when we're looking at two inequalities, they are either going to be an and or an or. That's it. And that there's a set of they're talking about when you graph them, this, like, here's the 4 graph looks that you'll have for an or to help you write an answer. They'll look like this for an or, and this is how you're supposed to write the answer, right? If you have an and, it'll be one of these 4 looks, and this is how you write the answer. Okay? So for compound inequalities, there's 4 different ways that you can graph for an OR, and there's 4 different ways you can graph for an AND. They look similar. I mean, they're identical as far as the setup. I mean, if you look at that one and then turn around and look at this one, they're identical, but how it's written, how it's interpreted means something. An OR means it only has to satisfy one part of it. That's why when you get to this top left one, they're both going to the right. I'm choosing, the A all the way to infinity, right? But for an AND, because an AND is only where they intersect, right? Only where they touch, only where it works in both. This scenario, they only touch from B to infinity. Do you see what I'm saying? So that's how how you interpret the graphs based off what they are will get you the solutions to the problems that you need. Okay, so the biggest thing is to do this. I'll have this video up probably later this evening. It's about take me about 30 minutes to get it compiled, and then about another 15 to get it up in YouTube and link it. But you need to go back and just watch it, listen and watch it, and think about it, or go to it and rework the problem, and then listen and look how I explain it and what I'm saying. Okay, because I'm saying a lot that you're not I wouldn't say you're missing, but you're not seeing because you're building on information that you're kind of not sure about. Okay, so what I need to do is build your confidence on what you're looking at, and then you can go forward and be successful. All right, I would do that before I even started working the homework. So you got a single inequality and you got double inequalities. Okay, and then you got absolute value inequalities, which are double. Right, they're an and or an or, a positive and a negative. Okay, so that's what I recommend. Not